if there's a steeper elevation, it means he's faster. So you are correct, and 4 is C. Does he go home in story number 5?
No.
So he left his home.
For a run.
For a run, so obviously it's going to be a little steeper.
J?
He was unfit and gradually came to a stop. Comes down there, here's his home, and it said he left his home to go for a run. So do you think it's going to be a steep line if he's running?
Yeah.
And then it says he realized he was unfit, so he came to a stop. Which graph does that look like? You see how it matches A?
Yeah, but he doesn't stop.
I know, but he doesn't stop. But isn't this section less steep than the beginning section?
Yeah.
So that means he's slowing down because he's tired. But in the beginning, he was faster. The home is always right here. When you're walking, your slope is not as steep. He bought a newspaper and then he ran all the way back home. So his back home, back to the x-axis, is going to be steeper. It could be D, but D is not ending up at home.
H?
But H doesn't end up at home. I does not end up at home. If you want to end up at home, you got to be on the x-axis. Which graphs end up on the x-axis? And they start from home.
No.
It doesn't?
Does.
I'm sorry, E's graph looks like this. Did I end on the x-axis?
Yeah.
Does this look like it could be it?
Oh.
I mean, he's walking to the store. He's in the store, he buys the newspaper, and then he ran home. He's on the x-axis, right?
Yeah.
So 6 equals E. 7.
I'll read it.
Okay.
Tom went out for a walk with some friends. He suddenly realized that he had left his wallet behind. He ran home to get it and then had to run to catch up with the others.
Oh, I know what it is. It's I.
Yes. As he walks, he forgets his wallet, and then he has to run to catch up with his other friends. Good job. So, do you see the graph that looks like this? Oops, can't write with that.
Oh.
You see the graph that looks like that, Bryant?
I was about to say.
H. Because look, how can he be going straight up? I don't think Tom can be going straight up and down. We have graphs J. We have graph B and G.
Mm-hmm.
All right, so
I
G.
know what 2 is, I think.
G says he goes back home, right? So, is there a number left that says he goes back home?
J.
A number, not a letter.
So J.
Where did Tom start in J? Tom started way up here, right?
Mm-hmm.
And walked slowly all the way home. So 9
Only
is
one
J.
left is B.
Yeah. So you're right. So B doesn't really make sense though, does it?
Not really, no.
Or it looks like they use D for 2.
Oh, D.
But I like B better a little bit. So I'll accept 2 for that, or you could have said D for 2. So you read your graphs in this direction. Does that make sense?
Yes.
Even if I gave you a bigger graph with more information, you would still read in that direction. You would still read in this direction. This is quadrant 1. This is 2. This is 3. This is 4. So 1, 2, 3, 4.
Okay.
A set of ordered pairs is called a relation. A relation can be depicted in several ways. An equation can represent a relation, as well as a table, a graph, and a mapping. This right here is an example of a mapping. And I'll let you guys read that paragraph. Domain values are your x's, right?
Mhm.
And your range are your y's. And x comes first and then y. So -2 leads to what number?
4.
4.
So does -1.
And that would be your next one.
Yes, so I did get it.
And then so you have 0, 1, and 2 as your other x values, right?
Mhm.
What y value goes with 0?
6.
Yep. And the y value that goes with 1 and 2?
8.
They're both 8. You only need to tell me your x's and then fill in that section right there. You only need to fill in this piece, 3 numbers here and 3 numbers here. Because they're all the same. Your ordered pairs, your table, your graph, your mapping is all saying the same thing. So I'm going to walk through them. Pretty much express the relation, well, they give you the relation as a table, a graph, and a mapping. And then list. So the example, I'm going to put -4, -1, 1, 2, and 4. Those are all my x values. My y values are -1. So everyone see where I'm getting these numbers?
Yeah.
Ooh, I forgot -4. And then you just you guys can do the graphing one, that's your ordered pairs. So you're going to list them all here. So -4 goes to -1. -1 leads to 2. Remember, do not repeat numbers. But this one doesn't have any repeated, so if you go out of the circles, it's totally fine. See how I went out of mine? And then you would just plot your circles on the coordinate plane. So does everyone see how I'm plotting them?
Yeah.
I think I might be a little off, but that's okay. And then what are you gonna list down here? The same, you're just gonna list the domains, right?
Yes.
Yeah, so you're just gonna do the same thing. So it's just a different way of representing them. Here you're still increasing, but it's just steeper. Here you're staying the same. You're decreasing here.
How much time is left in class? I want to know how long
What do we gotta start packing up? That was it. And you guys have to finish the rest yourself.